Hello everyone. In this video we will see balancing of redox reactions by using ion electron method. In the last video I discussed the balancing of redox reactions by using oxidation state method. So here we will see the balancing by ion electron method. Here ion electron method, it is also called off reaction method. Why it is off reaction method? Why? Because in this method first we will take the equation and we will separate the equation into two equal halves. One is oxidation half, another one is the reduction half, and we will balance individually, and finally again we will add these both equations. So hence we can call it as off reaction method. So again the rules involved, the steps involved in this ion electron method of reaction methods are like this. First we will see the steps one by one, then we will take some examples. Again the step 1. So in this ion electron method we have to identify first oxidation of reaction and reduction of reaction, and we have to make them separate. So first identify oxidation of reaction and reduction of reaction. Reduction of reaction, and make them separate. And make them separate. And the second step, after separating the two off reactions, we have to balance these off reactions individually. Balancing of off reactions, or balance the off reactions separately. How to balance? As like previous, means whatever the steps involved in the oxidation state method, the same steps involved here, except the first step. In case of oxidation state method, first we balance the change in oxidation numbers, but here not required. So what we have to do, the sub conditions here. So after separating, we have to separate the both of reactions like this. First balance the elements. Balance the elements as well, except oxygen and hydrogen. The next, balance the oxygen. Again, how to balance oxygen? By adding water molecules, equal number of water molecules. And the third step, we have to balance hydrogen. How to balance this hydrogen? By adding equal number of H plus ions. Again here same, they may ask to balance this redox reaction by acidic medium or basic medium. Here also both mediums involved. If it in a acidic medium, these three steps is required. Again we have to separate balance, but by using first three steps in acidic medium. If it is in acidic medium, these three steps are. If they ask to balance the basic medium, then we have to add extra step. What is that? And these four steps for basic medium, and these are for basic medium. What is that? Add OH minus on both sides. Equal to H plus ions, as like previous. Add OH minus and both sides of the reaction equal to that of H plus ions. And after balancing this, after using these four steps, in the last step here, the individual balancing, we have to balance the charge. Here, balance the charge by adding electrons. In case of oxidation state method, we initially balance the change in oxidation state. But in ion electron method, at the last step, we have to balance the charge by adding equal number of electrons. And after that, the third step. So sometimes we may get the electrons in the first half reaction and second half reaction, different number of electrons may require. In such case, first we have to equalize the number of electrons in both the half reactions. Equalize the number of electrons in both the half reaction again by multiplying the half reaction. Here we have to multiply the entire half reaction by multiplying the half reaction using suitable factor. So, and then the last, add both the half reactions. To get final equation. So we have to again, first we have to equalize the number of electrons in both the half reaction, then we have to add the both half reaction to get the final equation. So these are the steps involved in ion electron method. What is the first step? First we have to identify oxidizing and reducing half reactions and we have to make them separate. Over. The next step, we have to balance this oxidation of reaction and reduction of reaction separately. How to balance? Same rules whatever we followed in the oxidation state method. But here one exception, in the oxidation state method, initially in the first step we balance the change in oxidation number. But here not required, we can go with the second step onwards. Means balancing of element, next balancing of oxygen, and next balancing of hydrogen, and the last here in the first step in the case of oxidation state method we have balanced the change in oxidation state. But in case of ion electron method, in the last step we have to balance the charge. How to balance this charge? By adding equal number of electrons. Here we will use the electron to balance the charge. So after that, at last again we have to add both the half reactions. Before adding, we should take care that in both the half reaction the number of electrons should be equal. Well, because these electrons should be cancelled after in the final equation. In the final equation there should not be any electrons. They should be cancelled out. That is why we have to make both the half reaction the number of electrons should be equal. Now we will see some examples. So let us take this one example. Here dichromate reacts with iron 2+ and forming chromium 3+ and iron 3+. First we will take this in acidic medium. Again we will take check in both mediums. First one is in acidic medium. So balance in acidic medium. So what is the first step in ion electron method? First you have to identify oxidation of reaction and reduction of reaction. We have to make them separate. So to identify anyhow, first we have to identify the change in oxidation state. Then only we can identify which is the oxidizing species and which is the reducing species. Here chromium oxidation state +6, and oxygen -2 and iron anyhow the charge present on that +2 and a chromium +3 and iron +3. Now see iron chromium +62 +3. Here decreasing oxidation state. So this is a reduction of reaction. Is a reduction of. And iron 2 +2 iron 3 plus increasing oxidation state means what? Oxidation. This is the oxidation of. Now we will make separate. I will write oxidation of here. What is that oxidation of reaction? Iron 2 plus is giving iron 3 plus. And reduction of reaction. And reduction of reaction. What is the reduction of reaction here? And dichromate is giving chromium 3 plus. So now this is the first step. We separated both the of reaction. What is the oxidation of reaction and reduction of reaction. So after separating, what we have to do? We have to balance these both of reactions separately, individually, by using the same rules which we have followed already in the oxidation state method. So in that, the first step, first we have to balance the elements. So in the oxidation of reaction only iron is there, iron is balanced. So no need to balance the iron. Next oxygen, no oxygens are there here, no need to balance. Hydrogen, so no hydrogen, hydrogen also not required. So in here no balancing. In the last step, balancing of charge, one remains. Here iron 2 plus, iron 3 plus. Left side 2 positive, right side 3 positive. So in extra we have 1 positive. So how can we nullify this 1 positive? By adding electron. Electron is a negative charge. So we have to add 1 electron. How many? Equal number of electrons, which is the to balance the charge. Now here you will get iron 2 plus, iron 3 plus. Now we have to add electron here. Now 3 plus 1 minus, total 2 plus, and this side also 2 plus. 2 plus 2 plus. Now charge is balanced on the left side over this part. Come to the reduction of reaction. As usual, we have to balance this also separately. Here chromium. First we have to balance the elements. Here 2 chromiums and 1 chromium is there. So just you multiply here with the 2. So now elements are balanced. In the second step, you have to balance the oxygen. Here 7 oxygens and the right side no oxygens. So what we have to do? We have to add equal number of water molecules. How many? 7 water molecules are required. So oxygen is balanced. Next hydrogen. Now 14 hydrogens are there on the right side. On the left side we have to add 14 hydrogens. Now oxygen balanced, hydrogen balanced, element also balanced. Now the last step, we have to balance the charge. Now see here, on the left side 6 positive is there. So right side 6 positive, and the left side 2 minus 14 plus. Overall we will get 12 positive extra. Now here 6 positive, 12 positive. So excess how much remains? 6 plus remains on the left side. Reactant side we have extra 6 positive charge. Now this extra 6 positive charge we have to balance by adding electrons. So we have to add then 6 electrons. Which side we have to add? In the reactant side excess positive charge is there. To nullify this excess positive charge, we have to add in the reactant side only. So we have to add 6 electrons on the left side. Now these both of reactions are now balanced, including the charge. Now the final step, what we have to do? Again we have to add both the reaction. Before adding we have to check. So in both the reaction the number of electrons should be same. In the oxidation of reaction the number of electrons, here only 1 electron is there. In the reduction of reaction we have 6 electrons in the reduction reaction part. So what we have to do? So both should be equal. How can we equal? Just you multiply this entire equation, entire of reaction with the suitable factor. What is the suitable factor here? 6 only. If you multiply with 6, we will get 6 electrons. So now this oxidation of reaction now will become like this. Finally, 6 iron 2 plus will give 6 iron 3 plus and 6 electrons. Now this is the final oxidation of reaction and this is the final reduction of reaction. So after balancing the electrons, means after equalizing the electrons, we have to add both the off reactions. Now I'll add both the off reactions. First oxidation of reaction is what? 6 iron 2 plus is giving 6 iron 3 plus 6 electrons. Reduction of reaction, 6 electrons and Cr2O7 2 minus plus 14H plus is giving 2 Cr3 plus and 7 water. Now write this final equation, and here 6 electrons left side. Now here dichromate, Cr2O7 2 minus plus 6 iron 2 plus 14H plus will give, on the right side we have 2 chromium 3 plus and here 6 iron 3 plus and extra 7 water molecules. So left side completely over and right side also completely over. So this is the final balanced equation. Again, to check whether the reaction is balanced or not, first you check the charge balancing. Now here chromium 2 minus and 12 plus and 14 plus. So total how much we will get here? 24 positive. And the right side also 6 plus and 18, 24 positive. So left side and right side, both the side charge is balanced. Elements 2 chromiums and the 6 irons and 6 irons, and here 7 oxygen, hydrogen 14. Now everything is balanced. This is a balanced equation. So these are the steps in acidic medium. Now we will see the basic medium. One more example. If you take in basic medium, how to balance. So let us take this equation in basic medium. Now we have to balance in the basic medium. First, again as usual, first we have to separate both of reactions. First we have to identify which is the oxidation of reaction, which is a reduction of reaction. First find out your manganese plus 7 and your manganese plus 4 and iodide minus 1, iodine 0. Now plus 7 to plus 4, this is a decreasing in oxidation state. So this is a reduction of reaction. And here minus 1 to iodine 0, increasing oxidation state. So this is a oxidation of reaction. Again write separately, oxidation of reaction. Oxidation of reaction. What is that? I minus is giving I2. Right. Next, reduction of reaction. What is the reduction of reaction here? Reduction of reaction. Here MnO4 minus is giving MnO2. Now after separating the two off reactions, again we have to balance separately. First we will balance oxidation of reaction. Again the same steps. Elemental balance, oxygen, hydrogen. Elemental balance. Here 1 iodine, here 2 iodine. So here elements are not balanced. So to balance this iodine, just you multiply this with 2 minus. Now 2I minus will give iodine. Elements are balanced. So here no hydrogen, no oxygen. So no need to balance the oxygen and hydrogen in this case. So once balancing of elements over, next we have to balance the charge. So here to balance the charge, here 2 minus is there, and the right side no charge. So to get both sides equal charge, we have to add 2 electrons on the right side. Now left side 2 negative and right side also 2 negative. And now this is balanced. And come to the reduction of reactions case. Here MnO4 minus MnO2. Manganese element is balanced. Next, oxygen balancing. Here 4 oxygens, here 2 oxygens. So 2 oxygen deficiency in the right side. Now you have to add 2 water molecules on the right side. Next, after balancing the oxygen, hydrogen balancing. Here 4 hydrogens and left side nothing is there. Now MnO4 minus plus. So we have to add 4H plus. Why? Because 4 hydrogens are deficiency. Then MnO2 plus 2H2O. So now after balancing of hydrogen oxygen element, this is balanced. If it is acidic medium, this is over. But the question is in basic medium. So we need one more extra step. That is, now we have to add OH minus. How many? Equal number of H plus present here. 4 H plus are there. So we have to add 4 OH minus both sides of the reaction. Then you will get MnO4 minus plus 4H plus. Now I am adding 4 OH minus both sides. And this is MnO2, 2H2O, and this is 4 OH minus. Now see this 4H plus and 4 OH minus, they will give 4 water molecules. Now left side, reactant side water is there, product side also water is there. So we have to subtract that. Then overall we will get here MnO4 minus plus if you subtract 2 water molecules, the product side from the reactant, you will get 2 water molecules remains. And this will give MnO2 plus 4OH minus. Now everything, all elements are balanced, even in basic medium also. Next, after that, we have to balance the charge. Your charge 1 negative and your 4 negative is there. So 1 negative and 4 negative means right side still 3 excess negative is there. Then to balance the extra 3 negative, we have to add electrons. Which side? So anyhow this side negative is there. Now should balance the negative charge, we have to add electrons in the left side. So we have to add 3 electrons in the reactant side. Now both sides the charge will be balanced. What we will do? We will add 3 electrons in the left side. Now electrons, charge is balanced. Now this, and before we adding, now both the case of reactions are balanced including the charge. But in the final case we have to equalize the number of electrons in the both the case. Here 2 electrons, here 3 electrons. They are not equal. Then how can we make equal? By multiplying with suitable factor the entire of reaction. So what we'll do? To make both the case equal, I'll multiply this equation with the 3 and with this equation with the 2. So here 3 into 2, 6 electrons. Here also 3 into 2. Now we'll get 6 electrons. Both the case now electrons will be balanced. So then we'll get the final of react equation here. 6I minus will give 3I2 plus 6 electrons. And this is a of reaction. And here if you multiply with the 2, we will get 6 electrons plus 2 MnO4 minus plus 4 water molecules and 2 MnO2 plus 8 OH minus. And this is a final of reaction, and this is the final of reaction in this case. So after that, making equal to equal number of electrons in the both of reaction, we have to add both. Now if we add both the reactions, what do we get? This is the of reaction. 6I minus is giving 3I2 plus 6 electrons. Oxidation of reaction, and the reduction of reaction 6 electrons plus 2 MnO4 minus plus 4 water molecules is giving rise to 2 MnO2 plus 8 OH minus. Now we have to add this both of reaction to get the final equation. So 6 electrons left side and this is the right side, they are cancelled. And what remains? 2MnO4 minus plus 6I minus, and still water is there, 4 water molecules, is giving on the right side 3I2 and here 2MnO2 plus 8OH minus. This is a balanced equation in basic medium. Now again to cross check the first charge here, 2 minus and 6 minus. 8 minus is their reactant side and here 8 minus is their product side. Now the charge is balanced. Elements 2 manganese and 6 iodine and 6 iodine and 4, this is 8, 10 oxygens and 8, sorry, here 8, 12 oxygens, and the 12 oxygen they are balanced. Hydrogens, here 8 hydrogens and 8 hydrogens. Now everything is balanced. So this is a balanced equation. If you like this video, please like, share and subscribe to my channel. Thank you.